time to talk about the uncomfortable truth of the AI race and the broader technological race between the US and China. And I say uncomfortable because many of us still believe that the West is where innovation happens and that it will simply outpace China. You see this belief everywhere, in the media, in public opinion, and even in the stock market. Yet, this belief is false. China will surpass the US and Europe by a wide margin, and the gap will only grow as we move further into the future. My name is Michael, and like always, I bring you information that helps you position yourself and your investments in rapidly changing reality. To keep everything structured, we will start with big picture fundamentals and narrow down to technology and AI, which are just symptoms of a deeper shift. And to understand that shift, you need to understand one thing. At the core of economic growth, technological leadership, military strength, and geopolitical power lies innovation. Without innovation, no country can stay competitive. A country with more advanced military technology is more likely to win a war. A country with more advanced solutions make life easier for its people. A country with more efficient manufacturing dominates global trade. A country with better chips, cheaper energy, and more powerful algorithms will likely win the AI race. And innovation never appears out of thin air. There is a very specific chain of events that must happen every single time, and each step depends directly on the capabilities of real people. First, a scientist or highly capable researcher must make a breakthrough, a new material, a new method, a new algorithm, anything that pushes the frontier of what is possible. Second, an entrepreneur, engineer, or technically minded innovator must turn that breakthrough into something useful, a product, a tool, a technology, or a company. Third, manufacturing and industrial engineers must scale it, because even the best idea means nothing if it cannot be built efficiently and delivered to millions. And fourth, policymakers must support the process instead of blocking it, creating a regulatory environment that accelerates progress instead of burying it in delays and bureaucracy. This entire chain rests on the intellectual capacity of a population and on how efficiently that capacity is educated, organized, and deployed. And here the data becomes extremely uncomfortable for the West. China produces around 1.4 million new engineering graduates per year. The United States produces roughly 200,000 even when you include computer science. That's already 6 to 7 times more every single year. In broader STEM fields, China awards around 2 million STEM graduates, while the US produces under 1 million. And at the PhD level, the numbers are 50,000 STEM PhDs per year for China and 34,000 for US. Even on raw numbers alone, the input to the innovation machine, China has built much larger pipeline. But quantity isn't the full story. The very top of the talent pyramid matters even more. Innovation is not driven by average people. It is driven by a tiny group of exceptional scientists, the top 1%, whose work shape entire industries. These individuals publish breakthrough papers, create new materials, invent new algorithms, and expand the scientific frontier for everyone else. And China's share to this global scientific elite is rising sharply, while the US share is declining. China in recent years surpassed the US in the number of top 1% most cited scientists, high impact papers in material science, chemistry, engineering, AI, and quantum research, and the growth rate of researchers entering the global top tier. This shift didn't come out of nowhere. For decades, the US dominated not because it produced the most talent, but because it attracted the most talent. The world's best minds from Europe, India, China, and Middle East and beyond moved to the US because it offered unparalleled opportunity, funding, and the American dream. But that dynamic is changing. The US produces fewer top researchers domestically. Immigration has tightened. Global talent no longer flows to the US at the same scale. Meanwhile, China is producing more top-tier scientists every year. And because scientific progress is extremely concentrated, generated by a very small number of exceptional minds, this shift has massive consequences. At the same time, regulation creates yet another divergence. Even a brilliant society can be slowed down by its own system. And this is where the gap becomes dramatic. In the US and Europe, new technologies face enormous friction. Political gridlock, lobbying, endless committees and reviews, zoning battles, lawsuits, fragmented agencies. Building a chip fab can take a decade. Energy projects face endless delays. AI companies deal with constant hearings and regulatory threats. Startups drown in paperwork. China, on the other hand, optimizes for speed. When China decides something is strategic, AI, robotics, chips, batteries, automation, the path is cleared. Infrastructure is approved fast. Construction begins immediately. Manufacturing receives support instead of obstacles. This alone multiplies innovation speed. Now combine everything. More scientists, more engineering, more top-tier talent, more manufacturing capacity, and more supportive regulation. China has built an innovation machine the West cannot match under its current structure. And as China continues improving its education system, the gap will only widen. But even this is not the full story, because while most people focus on the current technologies, they completely miss the next race. The technologies where no one is ahead yet, because the entire foundation must be built from scratch. This includes photonic chips, thermodynamic or revisable computing, atomic scale manufacturing, quantum communication networks, next generation battery chemistry, biological computing. These are not incremental upgrades. They are fundamentally more efficient systems that bypass the limits of today's technology. Leading here is not catching up, it's leapfrogging. These fields reset the playing field. The question is no longer who is ahead today, the real question is who can build entire technological environment faster. And once again, China's structural advantage becomes overwhelming. Now let's shift to AI. A topic that gets a lot of attention but often from the surface level. Demos, viral clips and model releases dominate the conversation. Yet the real foundation of AI leadership is built on compute capacity, energy cost, scalability, and the ability to train large models repeatedly and affordably. These are the fundamentals that define AI leadership, and the data shows exactly how the US and China are positioned. In compute capacity today, the US still appears ahead. Recent estimates show that US controls roughly 75% of global frontier class GPU compute, while China holds around 15%. That's the legacy picture, built over decades of Nvidia dominance and Silicon Valley cloud giants scaling early. But the trend line tells a completely different story. China is approaching AI compute as a national infrastructure project rather than a collection of private initiatives. Its internal AI compute capacity recently exceeded 788 exaflops. It's projected to surpass 1000 exaflops by the end of 2025 and could reach over 3000 exaflops by 2028 under already announced buildouts, a rate of growth that no Western country is currently matching. On the physical side, the US currently operates roughly 5,400 data centers with 54 gigawatts of installed IT power, while China has about 450 centers totaling 20 gigawatts. But China is already building larger, specialized AI-dedicated facilities at much higher growth rates, with entire provinces developing AI compute zones from scratch, rapidly closing the gap and setting the stage for future expansion. What matters is velocity. China is not trying to match the US current footprint, it's building tomorrow's. And here is the real inflection point. Once China has fully domestic high-end chips, which is already progressing, the scaling rate will explode. This is the same pattern seen in solar manufacturing, EV batteries, steel, high-speed rail, and industrial robotics. In each industry, China started behind, built domestic supply, and then scaled 10 times faster than everyone expected. AI compute will also follow this pattern. As soon as supply chains bottlenecks disappear, China can deploy thousands of exaflops per year the way it deploys hundreds of gigawatts of renewable energy annually. In other words, the US currently has more compute, but China is building way more momentum, and we want it or not, it will overtake soon. Energy is also crucial. China has dramatically lower energy costs and can expand its grid or build new generation capacity far faster than the West. Cheaper energy means more training runs, faster iteration, lower cost per experiment, more aggressive research cycles, and in AI, iteration speed is everything. But even with compute and cheap energy, there is one more layer. The part that actually turns hardware into intelligence. The algorithms that can reduce hardware requirements by an order of magnitude. And as we discussed earlier, this is where talent matters most. Breakthrough algorithms don't come from committees or average workers. They come from a small group of exceptional researchers, the same top-tier scientific elite where China is now growing way faster than the US. These people shape entire industries with a single idea. And if we are talking about AI leadership, we can't forget about the next phase. This is robotics, the physical embodiment of AI. And this is exactly where China is already ahead, producing more robots than the rest of the world combined, deploying them across factories, logistics, hospitals, construction sites, and public infrastructures at scale, accelerating adoption with national robotic zones, industrial incentives, and massive real-world testing, and even hosting events like robot combat and humanoid showcases to normalize and popularize the technology. Robotics compounds innovation. Intelligent machines reduce cost, accelerate manufacturing, generate real-world data, and create a feedback loop that improves both AI models and the physical infrastructure. In the US, robotics advances through startups. In China, robotics advances through entire ecosystems. China is already at the next step of the technological race. West hasn't arrived yet, despite having legacy companies like Boston Dynamics. When you combine everything, talent, education, manufacturing, regulation, deep tech, foundations, compute, energy, algorithms, and robotics, the pattern is unmistakable. The story of China catching up is outdated. China is not catching up. China is building forward, and the West is standing still. Whether people like it or not, understanding it gives them an advantage, because the world that is coming will not reward nostalgia. It will reward clarity, and the money will follow the new world order. Let me know what you think about China-US race in the comments, and see you next time.